like springtime on this February morning in a courtyard, birds were singing.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today, with Sophie B. Hawkins in the background, we are going to study some composite functions. Let's get to it, shall we? All right, so composite function, you might think of it as a function within a function. Nice little verbiage here. There's different sort of notation. You're probably more familiar with the notation right here. But all of this is the same. You will see this notation in IB as well as this, but mostly this one, okay? And also this. It's also used to represent the composite function of f and g. It means f following g. And all a composite function is substituting one function into another one. And students usually get confused because there's x to the fourth here and 2x plus 3 here. But if I do f of g of x right here, f composite g, all that means is I'm replacing this x with everything that is equal to g of x. So x to the fourth, I replace the x with 2x plus 3, and it becomes 2x plus 3 to the fourth. Okay, and there's a little function machine description there if you want to pause and take a look at that. Algebraically, what we have, I just showed that. If f of x equals x to the fourth and g of x equals 2x plus 3, then f of g of x is equal to that. And I really like this notation because this really drives home the fact that I'm taking the function of 2x plus 3, right? And with f of x equal to x to the fourth, I'm just taking 2x plus 3 now and expanding it to the fourth power, okay? Okay, so let's do some examples here. Given that f of x is equal to 2x plus 1, and that I believe that with that notation you're supposed to say it as x maps onto 2x plus 1, but I always say f of x is equal to 2x plus 1. It just makes more sense to me. And g of x is equal to 3 minus 4x. Find in simplest form f of g of x. So I always like to rewrite it like this. F of g of x, okay? And so I work from the inside out to find f of g of x. I replace g of x with what it is equal to, and that is 3 minus 4x. So that becomes f of 3 minus 4x. Now I'm going to take a little time out here with this f of 3 minus 4x. I know that f of x is equal to 2x plus 1. Okay? So if I ask you to find f of 3, I know that you know that just becomes 2 times 3 plus 1, which is 7. And I'm not as concerned with the 7. What I'm concerned with is I'm replacing the x with the 3. If I said f of triangle equal, to find f of triangle, I would replace the x with the triangle. So f of anything, f of squiggly, would be equal to 2 times squiggly plus 1. Point being, whatever is in here replaces the x, and I multiply it by 2 and then add 1. It doesn't eliminate the 1, it just replaces the x, okay? So, well, I should be able to do that. I was going to get rid of that, but I don't think I will. Okay, so now this becomes 2 multiplied by 3 minus 4x plus the 1. And I cannot emphasize enough, all that happened here is whatever was inside the parentheses replaces the x in the original f of x function. And then I just simplify it. So this is equal to 2 times 3 is 6. 2 times negative 4x is negative 8x plus 1. And this just becomes negative 8x plus 7 after I simplify. Okay, so f of g of x is equal to negative 8x plus 7. Okay, so let's try b, and we're just going to work backwards there. G of f of x. Okay, so again, whatever f of x equals, I'm just going to replace it. So this is equal to g of, and f of x equals 2x plus 1, so 2x plus 1. And what is g of x equal to? It's equal to 3 minus 4x. So that means this 2x plus 1 replaces this x. The 3 and the minus remain. The only thing that changes is this x is being replaced with 2x plus 1. So this becomes 3 minus 4 multiplied by 2x plus 1, which is equal to 3 minus 8x minus 4, distributing the negative 4 through the parentheses, which becomes negative 8x. 3 minus 4 is minus 1. That's all there is to it. So g of f of x is equal to negative 8x minus 1. Now notice these are different. Sometimes they are the same. That's a special case. But generally, f of g of x is not equal to g of f of x. It's not always the case, but most of the time it's the case. All right, one more example to go. Okay, so they're saying find g of f of negative 1. Okay, so g of f of negative 1. Okay, so that means I need to find out what is f of negative 1. Well, f of x equals 6x minus 5. So I find f of negative 1, and that's equal to 6 times negative 1 minus 5, which is negative 6 is negative 11. So f of negative 1 equals negative 11. So I'm going to replace f of negative 1 with negative 11. So then this equals g of negative 11. It's really just a substitution. This is equivalent to negative 11, so I can replace it. And then it's quite easy. G of x equals x squared plus x. So g of negative 11 is equal to negative 11 squared. Plus negative 11 is minus 11. So that's going to be 121 minus 11, which is equal to 110. And then for b, I have, this is weird, like how can you do the same function? Well, it's quite simple. We're asked to find f of 0. So we're just substituting into the function first. Up here, I'll do f of 0 because that's what I need to replace in here. And f of 0, if I look at my f of x function, is simply 6 times 0 minus 5, which is equal to negative 5. So then this becomes f of negative 5. Why? Well, f of 0 equals negative 5. Let me just write that. That's our final conclusion from this work here. F of 0 equals negative 5. So I'm just replacing the f of 0 here with the negative 5. And now, since f of x equals 6x minus 5, f of negative 5 is equal to 6 multiplied by negative 5 minus 5. And this minus 5, of course, is just from here. So that's negative 30 minus 5. That is negative 35. And that's it. And with that, that is all I have for you today. Hope you enjoyed it, and we shall see you next time. Let's see what's going on here. Oh, Sophie B's still going. With Sophie B. Hawkins in the background, I shall say, I am out.
I feel so high, though I am not.